start recording. So now we are recording. So today we're going to talk about,
Hello.
yeah, hello.
Yeah, hello people watching the recording in the future.
Yeah, hello there. We're going to talk today about abstraction, the Descant. I think that's how you pronounce that. And whatever is the title of the next one, which I always forget.
The quality without a name.
Yeah, I really want to talk about that one. I really, really do.
They are eyes without a face.
Okay, but let's talk about this one first. So we're going to criticize abstraction, right? We're going to criticize abstraction. That's basically what this thing is about. Oh, sorry. And this is sort of a strong start because it talks about that in other areas of human knowledge, we question the use of abstraction for various reasons. This quote is great for starters. We have seen that abstraction plays an important role in the discovery of knowledge. Abstraction seems to be a negative procedure because it omits stuff, and it is therefore should be interpreted as a bold intellectual move because it can misfire. And then there's this other quote, which is also great. No abstraction is possible without losing, in certain cases, no abstraction is possible without losing the thing we wish to study. Thus, study at a certain level can only go so far, and it must give way to less through abstraction. That is, a less shallow level of analysis. So basically, this start is kind of saying that in other areas, it is considered something to be taken very carefully, the act of abstract.
Given given their if you look at a random Java library, most likely it has more abstractions than it needs to have.
Yeah, no, but you
But
are jumping steps. This is
yes.
abstraction in outside of CS. Then we go to abstraction in CS, which is this. Well, this is the definition of the author, and let's go through it. So it's divided in two parts. The first one is the identification of common patterns. An abstraction represents a common pattern and provides a means of specifying which variation to use. And the second is the separation of concerns, in which you can ignore the exact uses or instances of the abstraction, and the user of the abstraction can forget the details of the implementation so long as the implementation fulfills its intention or specification. So what is the most basic example of this? A function. A function is the first level of abstraction of anything. Even if you consider like in an assembly language, right? So you can do a call.
Yeah, basically you're saying there's this chunk of code and I can pass these parameters to it. And the parameters are the systematic variation that is mentioned here in the and the chunk of code that takes those parameters is the common pattern essentially, right?
Exactly. And how do you do the variations? Via the arguments. That's how you do the variations.
Yeah, you call the procedure or function, you give it the arguments specify the particular variation that you're going to use.
Exactly. But there is a subtle detail that goes on here that it kind of bothers me because it says the definition does not directly mention ignorance or omission, though it does imply them. The common pattern is omitted, such as via a function, a macro, or a class. The structural behavior of the common pattern is lost except the name of the abstraction denotes it, and the definition of the abstraction, its implementation contains it. And the foregoing definition does mention the interests of particular people, abstraction implementers and abstraction users. Yeah, so there is this sort of relation that the author establishes between abstraction and ignorance. And I think that's a very dangerous word to be used because they are trying to do a relationship between ignorance, shallowness, and abstraction. And it's not wrong technically speaking, but I would say, very based on my experience and reasoning, that it is very deep and very not ignorant to identify which abstraction fits best.
Yeah, that takes us some level of discernment, right?
That takes some level of
Because
discernment.
if you try to use an abstraction that's not the actual abstraction that you should use, you're gonna have a mismatch, and it's like,
And you're gonna talk about that. We're gonna talk about that.
yeah,
Hmm. But I think this should have like you read the text, these relationship between these three words they keep being reaffirmed. So ignorance, shallowness, and abstraction. And I think the flip side of this coin is that the identification of the abstraction is the deep move because you can abstract pretty much anything. But what is the best one? I think it's not shallow at all to have this ability. I don't think it's ignorant at all to be able to do that. But let's continue. So then we go through some definitions that we talked before. So compression, habitability, and piecemeal growth. So just as a reminder, so compression is a piece of text that the meaning of any part of it is larger than the particular piece has by itself, um, which is basically a rich context, with each part of the text drawing the meaning of the text itself is drawing from the surrounding context. Habitability is the characteristic of the source code that enables maintainers coming to the code later in its life to understand its construction intentions and to maintain it, like modify it and debug it and so on. And then we have the piecemeal growth, which is based on repair rather than replacement. Um, and we talked
yeah,
about this in the last session because the whole idea that the problem the requirements list is static and that forces you to have a more replacement mindset. And because the real world is dynamic, we are trying to use the repair verb instead of the replacement one.
yeah. It's like, oh, we have a new requirement. Let's add a new feature. And oh, I found a bug. Let's fix this thing, right?
Hmm. So then we're going to talk about the one of the bad effects of abstraction. So one of the bad effects is when an abstraction is taken too far. What does that mean? It means that the result code that is structured like a big web in which groups of abstractions are tightly interwoven with others by means of interfacial glue. Let's see one example. If one abstraction is used in many places and that abstraction's interface is wrong, then repairing it forces the repair of all its use cases. That makes complete sense, right? So
Yes.
if you made an abstraction and you made an interface so the clients of the abstraction can use it, and that interface ended up being not good and you have to repair it, that will have a side effect of repairing in all its call sites.
Yep.
That makes sense. The more the abstraction is shared, the more repair will be needed. But such repair is dangerous because it's usually made with less deliberation than the original design in the context of unexpected requirements. So now we are putting the blame, well, not the blame, but we are putting the risk on should we even consider to change it? Maybe we are being a little bit, it's too early of a judgment. We should not change it actually. If the repairs are being made by people older than the original designers and much later than the design and original implementation, the likelihood of mistake or ugliness will be increased. That is true assuming bad training. So if you have people that are maintaining some code in which the original creators are now not there, the only case in which the likelihood of a mistake increases is if the new maintainers were not trained correctly. Which is fair to say. A lot of lack of training happens in many organizations.
And well, ChatGPT and Gemini, whatever, they make this problem worse.
They definitely make this problem worse. They definitely
Let's
make
be
this
real
problem
here.
worse. Um, um, yeah, so here's another example. And now we're using compression. The meaning of an expression written in the context of the web is determined by the context of the entire web. If you need to change another part of the web, so like because the idea of compression means that the meaning of it comes from its surroundings. If you change the surroundings, now you're potentially changing the compressed expression as well.
Yeah.
This gets worse the more mutability you have.
Yeah, like the more mutability, if you're working in assembly, the more unstructured code, yeah, the less crisp are the boundaries within your code, the easier it is to fall into this trap.
Exactly. One of the reasons that the author points out for that causes this particular problem is the use of abstractions throughout at all levels. So if instead there were a level at which they could become direct rather than indirect, this might be less likely to happen. So instead of using abstractions all the way through the stack of the software, at some places you actually do the copy pasting instead. It's a very how can I say? It's This happens when you know that the abstraction is making things worse, but it's not always that you can identify that preemptively. Sometimes you fall into that trap and you want to notice that later on the line. And then he comes and say that the people are thought to value abstraction above all else, um, but then that can lead us to inappropriate use of abstractions. And then he goes to something that I agree, which is the abstraction must be carefully and expertly designed, especially when reuse or compression is intended. However, because abstractions are designed in a particular context for a particular purpose, it is hard to design them while anticipating all purposes and forgetting all purposes, while the hallmark of the well-designed abstractions. So basically, let the pros do it, essentially. So if there is something that can, if fucked up, can do a lot of destruction, maybe you should consider letting the pros do it.
Which is fair, but also it's like,
Are you
can't
not
you
a
just?
pro then?
Yeah, exactly. That's like, dude, can we not just like try to be better? I guess improve.
That was exactly my criticism from the last session. But this time around, there is a mention of that later at the end. We're gonna go there. And then he goes with with what Marinho, lack of what Marinho just proposed, which is that average programmers are not well equipped to design abstractions that have universal usage. Even though the programming languages used by average programmers and the programming language texts and courses average programmers read and attend to learn their trade, emphasize the importance of doing exactly that. Although the designers of programming languages and the authors of texts and course instructors can probably design the abstractions well, the intended audience of the language cannot and are therefore left out. That is, that encouraged abstraction leads to less habitable software because it's expected inhabitants, average programmers working on code years after the original designs have disappeared, are not easily able to grasp, modify, and grow the abstraction-laden code that must work on. So again, this only makes sense if people don't improve. Both on both sides. So you don't improve, hence you are not a pro, hence you are not gonna feel confident making your own abstractions. And second, you don't improve, hence you cannot inherit the created abstractions. Um, which, well, if people don't improve, yes, those conclusions are correct. But that's a very bold assumption to say. Yeah, not everyone is a poet. Yet we seem to expect that the equivalent of poets will use high-level programming languages because only one program poets are able to use them. In light of this observation, is it any wonder that abstraction pure languages like C are by far the most popular and the abstraction-rich ones like Lisp and Smalltalk are the niche languages? That's a causation relationship being established here. That is kind of bold to say such thing. He's basically trying to establish that the popularity axis is being mandated by the the how good the language is in terms of making abstractions.
So basically, he's saying C is popular because skill issues.
Exactly, exactly. Which is kind of bold to say, given that Linux is made in C, and Linux is by one of the most loved and used pieces of software of existence. And are you saying that all the Linux developers have strong abstraction skill issues?
I mean, it's kind of difficult to write a piece of code that's supposed to control the hardware, right? It's the operating system. And you don't have a language that lets you control the hardware like C. There's an additional factor there that's not being considered, I guess, in this statement.
Yeah, not only that, but I also think it's a causality relationship that I never heard before. To me, it was more like how can you say, um, a timeline thing. C was chosen because was the best of its time. It was not chosen because there were well best according to a criteria that we can discuss later, but it was not chosen because hey people, we are dumb, so maybe we should pick a dumb language. I don't think that's how it worked.
If he had replaced C with Java, then I would be more likely to agree. But then again, Java nowadays is getting better, so I don't know. That may not be fair.
It's definitely not fair, but again, I don't think that was the reasoning, and I don't know the data to support this claim, but it is an interesting thought nonetheless. Um, okay, so now we go to uh, to the double-edged sword segment, let's say, because let's continue. The interface of a complex abstraction is likely to expose the implementation because portions of the abstraction interface are likely to be dedicated to assessing particular behavior. Unexpectedly, design and ad hoc abstractions frequently suffer from this shortcoming. Once the implementation is even partially revealed, it becomes more difficult to change the abstraction's implementation without causing problems. If the abstraction were limited to simple cases, especially those with a fairly universal meaning, like the well-loved and ubiquitous stack, a favorite of almost every paper on abstract types, this problem would be reduced. So basically, he's saying that as the abstraction gets more complicated and more complex behavior is added, there is a very likely chance that we're gonna be exposing implementation details. When I read this, the first thing that came to my mind was Raylib functions, because Raylib functions they have it's not weird to see in an example and a function having many new arguments. So the example is calling a function, but it's not leveraging any of the variations specific use cases, and then you pass a new pointer as the argument. And why that's the case? Because you're not using those arguments. That's not important for your particular use case. But these arguments must be there because of very specific implementation details of that particular function. So I thought of that. And then we go again to the idea that I criticized before, which is that complex abstractions arise from the observation that abstractions are about ignorance. Uh, because the idea of encapsulation is that the implementation is hidden, therefore preventing assumptions from the implementation. Some complex abstractions contain information about the implementation that is legitimately required, such as its performance, algorithm, coding tricks, and resource usage. Uh, when the implementation is truly hidden, its use, yeah, this statement is crazy. When the implementation is truly hidden, its user is forced to use real scientific methods to infer or discover the needed information. Rather than preventing assumptions, hard encapsulation tends to guarantee incorrect ones. So this is a double-edged sword. So because if you make it too customizable, you're gonna leak. But if you make it too black, you're gonna you're gonna protect information that the user wants to know. So
Yeah, that's
what to do then?
yeah, that's a very tricky business to be in, right?
Yeah, this is it's basically like a how
It's
do
a
you say in
tug of
English?
war.
Exactly, it's a tug of war between if you make it too customizable, you're gonna leak stuff, and if you don't make it customizable, now I'm gonna have to discover if my assumptions are correct, and given complete encapsulation, I'm gonna have to discover it myself. So that's a pretty interesting tug of war there. Yeah, so then there is another consequence. If the implementation is truly hidden and there is a need to make a change or add behavior, the user is reduced to reinventing. If the implementation is not only hidden but also protected, we're going to do copy pasting, and now we're going to have to maintain the copy pasted parallel version. That implies that later changes to the code will be less efficiently made because similar code was implemented in several places. Uh, and this majorly happens if the programmer is new to that code.
Yeah,
Uh,
because he may be aware of one occurrence of this copy, but not the other, right? Because he's new to the project, he doesn't know everything yet.
yeah, but like with the tooling that we currently have, who would consider doing so?
Ah, but that's the key word, Lemos. Currently, this book is old.
Well, I know, but uh, I think it's important to uh, focus on that because this is such a like you're gonna be unable to see how something works, and you rather copy paste it. Actually, not in this case, not copy paste it because if you are copying from somewhere, you found it, right? This is assuming that the thing's protected, so you didn't find it, hence you are implementing yourself. Who does that? I can only see that if the version that is protected has over the top functionality that you're not going to use, and you are willing to spend the time in making a simpler version yourself than having to cope with the trade-offs of the over-the-top version. That's the case that I can imagine. But in assuming that it's exactly what you need and it's exactly what you want, nowadays it's kind of uh, no big deal, I would say. And then we go to the dilemma that I mentioned before. Complex abstractions sometimes review information, which limits opportunity to change their implementations, and they're also intended to hide implementation, which forces programmers into ignorance and its resulting frustration, ineffectiveness, and feeling of denied responsibility. Uh, the
Ah,
go?
strict abstractionists. What kind of word is abstractionist? Like, I did not expect to see this word here, but okay.
No. They would argue that it's far better to hide implementation, but then we go back to the thing that I disagreed, which is that when people lose a sense of responsibility for the environment they live in and realize they're merely cogs in someone else's machine, how can they feel any sense of identification with the community or any sense of purpose there? This is basically an ego person saying that I cannot feel, I cannot identify with this community because I'm maintaining something that I didn't bootstrap myself. I don't know how to call that person aside from egotistical. I don't know if you feel similarly, but that's how I feel.
That sounds like narcissism, I guess.
Yeah, exactly. But again, this argument was made in the previous chapter that apparently people feel a lack of purpose if they didn't participate in the creation of something. But if that was the case, most humans would be dead because most of us are doing slash maintaining something that someone else created or discovered. Like, are we just gonna keep alive the who discovered the cure of cancers? Like, how does that work? It's kind of it's kind of weird.
Yeah, it is. It is kind of weird.
Like I fully don't understand. But maybe it's just us. So most of these problems can be eliminated or reduced if the user is encouraged to build small abstractions only, which I agree. This is easier if the language provides other mechanisms that help the programmer build the larger structures needed in a program, structures that were normally constructed from abstractions. This is something that I'm very curious about. What type of language mechanism would allow you to build the larger structures and that would not be an abstraction?
Hmm. Well, okay, I actually have an example.
Okay.
It's fulcro.
Elaborate?
You have to know how the DB works, like the normalization rules and all that, and how the queries and the idents work with that. Like those are not abstractions, and yet they are essential for composing components that may not know more. They may not know about their
Wait. How are they not
children.
abstractions though? I don't understand. They are
Like you need
IDs of a DB. A DB is an abstraction.
hmm, that's the kind of the point. It's not really a DB. You have to know that it's actually a big map, and the rules of normalization are, well, what the library establishes. Like you need to know that stuff to use it effectively.
Uh,
Like the Fulcrum DB in quotes is really just a map that has a particular structure.
no, yeah, I understand, but you don't agree that Fulcrum is doing an abstraction process there? It's literally
I
doing the
I
allowing you
agree
to.
that
Okay, go.
you can call it an abstraction, but then I would argue that it's a bad abstraction because you need to know how it works in order to use it.
Well, but that's the tug of war that we were talking about, right? So some complex abstractions require you to know some stuff.
Hmm.
Uh, which is, well, actually, you gave me an example because this I couldn't imagine. Like, who cares if I'm using a merge sort or radix sort or quick sort? Who cares? But then you found one example for me, which is fulcrum. In order to use it to its best, you must know the implementation details.
You must know how normalization works at the very least.
Exactly. So that's one example. But again, I have a very, I would be, I'm very interested to know which language mechanisms would allow you to compose larger structures and that would not end up being an abstraction. So I haven't found one yet, but definitely.
Uh, well, maybe the point here is to just use composition in this case, right?
Composition. Well, but if you're composing functions that are abstractions, you create another function, which is an abstraction. Like, again,
But if you compose it and just immediately call it, you don't give it a name. You just run it in line.
but is the problem the act of giving it a name then? Because
Uh,
that's not what's written here.
Let me try to put it another way. Let's just see an example. Well, let's actually use Zig as an example because screw C. Would you consider a sequence of statements to be an abstraction?
Yeah,
Like if you have a statement and you put another one after it, would you say that this is an abstraction?
of course it is. That's abstracting what the assembly is abstracting, which is a bunch of electrons going to memory.
Okay, it is an abstraction at that level, but that's not the level I'm interested in.
Sure then. Okay, continue with the thought process.
Like, what if instead of making like a function, you just inline the definitions and now you have a long sequence of instructions?
And
Is that
then
an
you,
abstraction?
well,
It's just composition, right? It's one after the other, but you're not actually abstracting anything. You're just saying, okay, here's the thing. It's very long. It's a sequence of, I don't know, 400 statements. Do the thing.
um, I guess I can see what you mean. Interesting, interesting. When you couple this device, yeah, then we go to that. We should build the hierarchy slowly, keeping as shallow as possible. We might find that we have paved the way to habitability, piecemeal growth, usable compression. Um, and if you put those things together, they are more likely to be correct because they evolve. Their use evolves over time. It's more natural that way. There is a problem. What if we do this for like decades? Isn't the end result big?
Well, yes, because if you grow slowly over a long time, you will get big,
Yeah,
even if
but
you
then
did
it's not
go slow.
shallow.
It may not be. It may still be shallow, but just be very wide, maybe.
Um, okay, so we the advice here is then there is some depth threshold that we need to respect, apparently. And such depth would allow us to keep the habitability, piecemeal growth, usable compression.
I
Is
don't
that
think there's a hard line, but that's my reading of this paragraph. Yes.
okay? And then we go to the C++ quote, which is basically yeah again. And then there's this efficiency thing comes kicking in, which well we're gonna talk about it. Well, it's gonna talk about it in the next section as well. Uh, but anyway, so this is basically saying summary that you are well they are saying I'm not saying that but they are saying essentially that you are a fool if you think that it is possible for a programmer to take an arbitrary class and derive a new useful and correct subtype from it unless that subtype is of a very specific kind anticipated by the designer of the base class. So they are basically saying you should not have the expectation that if you try to extend a base class and you are not the original designer of the base class, you'll be able to pick any base and derive a new useful one.
There's one objection I have to this quote in particular, which is like in an OO language, subtyping and subclassing are not actually the same thing.
Elaborate.
Like, would you say that a set is just a subtype of a multiset where you are constraining all of your frequency counts to be 1 or 0?
Uh, okay, the question is weird. Would I say that's correct or would I say that's useful?
Is it possible to define a set that way? Is the question.
If it's possible to define a set that way, I think so. It is should be possible.
Okay, that is correct. It is possible. Then a set would be a subtype of a multiset. But here's the problem. If you define a set as a subclass, not a subtype, but a subclass of a multiset class, then there are actually methods in the superclass that break the invariance of the subclass.
That's true.
You see the problem?
Yes. Yes, that's a very good example. Multisets. Well, anyway, then they make this quote is also making the strong claim that that being able to extend a class hierarchy is nearly impossible, though they don't provide a reason. The best that he came up was that the many possible extensions require access to the internal implementation of a class, and the author of the class either does not know what parts are needed or wishes to retain the opportunity to change the implementation and therefore hides the implementation.
I
In C
actually read about that example in a paper, but I don't remember the paper exactly. There was more detail there.
hmm Uh, anyway, so the need for speed encourages class authors to make virtual as little as possible. So this is basically, again, there is an efficiency thing going on, and about the extensibility of the classes being fully extensible being basically impossible according to these authors. But regardless of the reasons behind they think that, this statement saying that an unanticipated extension is difficult supports the claim that during the growth of an abstraction web, one must frequently go back to existing abstractions to repair them. So to repair being a sort of delayed anticipation of the extensions, which is fair to say. Uh, you have to go back to the original abstractions. Uh, well, and not repair them themselves, but reconsider their use cases. Maybe you picked the wrong one.
This sounds suspiciously like the notion of technical debt, actually.
No, yes. Like in a world where you don't know which correct abstraction you choose to solve a problem, and you're trying them out by trial and error. The more naive you are, the more tech debt you're gonna get.
Yep.
Um, yeah, this parallel is also, I don't know if I agree with that, but let's go. Because abstracting a common pattern and using the abstraction is a process of replacing something directly expressed by a shorthand, adding an abstraction is like adding a new word to a real language. It requires learning a new vocabulary. Real languages rarely permit us to add new words, and such words are reserved for concepts, objects, actions, and qualifications that are basic or nearly basic.
Lewis Carroll would like to have a word about this.
Is that a linguistics?
He's a writer. He wrote Alice in Wonderland.
I see, I see. Yeah, yeah, yeah. We don't invent new words for dogs that can jump through hoops or automobiles modified to carry 300 gallons of fuel. First, there is no need for these words except within a small family-like circle, and even there, the need soon dissipates when the name of the dog or phrase like Joe's Big Fueler prove worthy and effective. Second, these words would be meaningless outside the small circle that might need them, and encountering an enclave of odd language users would negate the advantage of natural language. Similarly, we want to limit the use of abstraction to either common items or items inextricably linked to the application domain. Otherwise, unnecessary abstract code would be unintelligible to programmers fresh to a project and hence it would not be habitable. This again, there are a couple of assumptions going on. Second, your hiring process sucks because you're basically saying that if if you guys talk about monads, the guy that just got in, he doesn't know the term monad.
I think he's more talking about the whole joke of abstract builder factory factories.
No, but that also goes to the same to the same. This is also an example of the monad. Like we can joke about it because we like to joke about Java all the time, but it's the same kind of thing. If I go to you and say, "Hey man, I have a problem. This is not working. My integration test is not working," and then you say, "Have you considered that this thing that you're using to test is a monadic thing?" If I don't know what that means, what that term means in our quote natural language, two things will happen. First, I'm gonna have a hard time understanding what you mean. And second,
Yep.
someone gonna have to educate me because otherwise it may be very inefficient for you to teach me all of that in order to, I don't know, reach a deadline or something. So his argument is that the abstraction additions, they increase the vocabulary, the glossary of the communication, which is true. But there is a reason we do that. The reason is because it's very freaking convenient to not have to explain things every time. Because if that was the case, if we only had to explain something once, we would not name things. The
Yeah.
reason we name them is because we're going to refer to them later. So you saying to me that, hey man, there is an overload on the communication layer of the team of the people involved. You with the new name that you're going to use for the abstraction, that's gonna suck for the new people. But then my counter argument is, uh, have you reconsidered the new people? like, and again, I'm not against training. I'm not against you hiring someone that doesn't know the shit, but is willing to learn it. But in this context, we are talking about something being inhabitable. So you are basically doing a disfavor to yourself because you are choosing people that you know ahead of time that they will not be feel at home. So like,
I I just thought of a very silly example. Um, Imagine that you somehow build a time machine and you go to the distant past and you take a caveman and you bring him to the present and you put him near a toilet. He would
yeah,
not know how to use the sink or flush the toilet, right?
yeah, Exactly.
Does that mean the sink and the toilet are not good?
Yeah. Exactly. That's a perfect way to put it. So I understand that if you have not joke, I'm not like this is a double. No joking, no pun intended. But if you make an abstraction factory, a factory that literally pumps abstractions all the time, at some point, if you have, let's say, more than 15 custom homemade abstractions for your company, that's already a lot of words. 15 names, just for starters. You can even make some combinations of them and make them like a super monad or something. That I can understand the overhead if you go that far, but just by using a couple of them, such as a function, a macro, a monad, I don't see that being that much of an overhead in terms of the communication layer. It's actually better so we can refer to things more rapidly. I can just say, dude, this is a monad. And then the other person will immediately understand what's wrong.
Yeah, as long as you don't call things abstract strategy builder factory, you should probably be fine.
Okay, let us continue. But then we go to the no abstraction. There is a chance that in certain cases no abstraction is possible without losing the very thing we wish to study. Which basically means that the thing that you are omitting, the thing that you are ignoring, is the thing itself of the study subject. Which, well, that may be the case actually. That may be the case. Uh, and then we go again to the clash of definitions, because now we're going to say that the abstraction is overloved is that a complete program full of the right abstractions is perfectly beautiful and justified by success. Alexander will probably not think that that program was beautiful, and then we go to a quote. Uh, Plan development is also generally not coherent, not in a deep felt sense. It is supposed to be, but if we ask ourselves whether the final product of current urban design projects actually is coherent in the real deep sense that we know from traditional towns, then we must say no. The order is superficial, skin deep, only in the plan or in some contrived orderliness of the arrangements. There is no deep inner coherence which can be felt in every doorway, every step, and every street. This modern plant development, which we think as normal, certainly has no power to evoke deep feeling. It can at best ask for some kind of admiration for design, but of deep feeling there is no word, not a tremor, not a possibility. So basically, and this will continue in the next section of this chapter, Alexander, which is also what Gabriel is trying to go for, they have a feeling that uh, how to say this? They have a feeling that beauty is related to organic growth. Organic growth, which means that there is no authority that can plan anything in order to reach its success, and it will be beautiful.
That is fair, but that assumes that only authorities can make plans, which is plainly wrong.
No, not a, no. Authority was just an example. Was just an example. They are talking about any plan being made by an authority or not.
But like, this is basically trying to imply that the
Man, my camera today. Yeah,
this is
go.
basically trying to imply that there was no planning going on in traditional towns. And if you look at planning from the perspective of the sense of planning that he's talking about, yeah, there's no such plan, but like at the very least, each house was planned by the people who built it, right?
Yeah, there is some sort of like level, because if you are in a local planning, I think these guys would say it's okay, but they are probably talking about like an upper
Global
level,
planning. Yeah,
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 yeah, global
yeah.
planning.
This reminds me of Hayek again.
Exactly, exactly. And he's gonna go further because the whole chapter about the quality without a name is basically saying that quote chaotic and organic growth is the way to achieve the quality without a name. The problem is that we don't really know how to define that. It's very imprecise, so we have loose terminology that we try to use. Well, I don't know if we're going to achieve that because we have 15 minutes, but that also I'm going to mention this book when we reach that because it's a very interesting area to study. Like, what is the quality without a name? Everyone can feel it. It's there, but we can't
But it,
name it, and we can't it's hard even to describe what it is.
yeah, when I was reading that chapter, I was reminded a little bit of Taoism, actually.
Mm, very interesting. Uh, well, let's go there. So the area of Alexander has the advantage of having a long history and hence a lot of examples, which is not the case. And when Gabriel made this about software, and then, but anyway, he's trying to make this parallel, and then therefore, the perfectly beautiful program is possible only for very small programs, like the ones in books on programming or in programming courses. Now let's return to the definition of abstraction. One thing that strikes me about this definition, now that I have, well, that he's been using for years, is the degree to which the fact is ignored or forgotten that there are two conditions for abstraction. There is not only a common pattern, but also systematic variations. Subroutines and functions are perfect examples. The common pattern is the code that ends up in the subroutine, and the systematic variation are the arguments. What about common patterns without systematic variations? I'll return to this later. Um, and then he goes about one of the lessons of this chapter, which is to say that excess of abstraction disease. He tries to defend himself, saying that abstraction is not bad, but to show that maybe some other concerns of software development, creating habitable software that can effectively be maintained, recognizing the reality of software development, piecemeal growth, and to plan accordingly. Which is kind of ironic because we are planning, but we just established that planning is bad. Like it's
Yeah,
kind of
again, it would be yeah, it would be like yeah, it's what I mentioned, right? There's this distinction here of level between having a global plan for everything and having a local plan. I don't think they have a problem with a local plan at all.
yeah. I think they have uh, yeah, but they don't talk on these terms. We're kind of overloading. We are trying to pick their pieces and make a Tetris. So we are kind of adding and like changing a little bit of the semantics to say, okay, planning must be related to some sort of layering or something, levels or depth, because we know for a fact that they are okay with planning, but they don't want some specific kind of planning. And our interpretation of the text says that what they must be saying is that planning on a global-ish scale is bad, but planning in a local-ish scale is okay. Um, well, let's continue. Uh, then, well, this essay starts with the definition of abstraction again, and this quote: "In order for the building to be alive, its construction details must be unique and fitted to their individual circumstances as carefully as larger parts. The details of a building cannot be made alive when they are made from modular parts." Yeah, so there is an attack on modularity. This is also going to continue in later parts of the text. But let's see.
Uh, Mind you, this is not an attack on general modularity because he's not against bricks and such, like bricks and planks. He's not against modularity on that level. He's against modularity in a larger scale. This is like spoilers from the future, basically, but
Yeah, but we are not defining the scale.
yeah, and that's the issue when you take this chapter in isolation, right? He's not mentioning that here.
Unfortunately, these patterns that we're trying to the common patterns, they are turning into abstraction with the unsystematic variations being lumped into the systematic ones, the result being an ad hoc interface. Such ad hoc abstractions, client code, so the ones that are using the abstraction, can end up being composed of glue code surrounding invocations of the ad hoc abstractions. The glue code, however, may not only to contort the natural structure of the client code. Notice
May
how these
only, yeah.
not may only to contort, yes. Notice how this affects compounds other problems with abstractions. If an abstraction is composed of what amounts to a conglomeration of somewhat related operations, programmers are more likely to want to modify or add to the abstraction, which is fair, right? So if you are using an abstraction and you're noticing that every time you need to use it, you need to do something else around it, your first instinct is that there are two possibilities. Maybe you are just having a sequence of coincidence. So every time you use this, you have to do this. Or the abstraction may be enlarged by adding this conglomeration of surroundings. And then you have the temptation of to add or modify the abstraction.
Wow, it's already ugly, right?
Well, to Gabriel it is. Then
No,
we go
no,
to
that's literally in the text. It's ugly enough to begin with, so
yes,
what's the
yes.
harm?
That again, that's why I said to Gabriel it is. Um, and then we go to an example in Common Lisp, which is like if you have a function that have optional arguments. And so we're going to use the mismatch function, right? So the mismatch function, um, and this function allows you to take, for example, the direction of the search, a function to test whether two items are the same and whether the predicate should be negated. And then he says that this example contains a number of common parties without systematic variations. And then it begs the question: what would be a way to implement this using whatever he's calling a systematic variation, because he's calling arguments not systematic variations.
Even though he called them systematic variations earlier.
Yes. So what would that look like? What is a systematic variation?
That's a good question.
Yeah,
uh,
that's a good question. So I was a little bit bothered by that. Let's continue.
I think in this case, the reason he's saying they are not systematic is because most of those arguments are optional for this particular function. And like one of them is even redundant, right? Because you can negate a predicate like without using the flag in the mismatch function telling you to negate the predicate, right? That's like purely redundant.
Mm, I see. That's true. Okay. That explains a little bit. Um, Then we go to the quote of abstract type, which is basically like we're basically making the abstraction tower, the tower of abstractions. So after this, we had the statement, then we had the procedure, then we had the interface, and what is the next step after that? What Alexander seems to be saying is that if you try to use modular parts, solid building blocks not easily molded to the current circumstances, then the overall structure of the thing built with them may become overly constrained by their shape. What does that mean? That means that you have something that doesn't, it's not a one-to-one with whatever you're looking for, but you can make it work. And everyone had felt this before. You are trying to do something and you don't have at hand an immediate solution, and you look at your toolbox and you see something that may not be a perfect fit, but you can make it work. You can jam it into the thing and then put some glue on it, and it's probably going to work fine.
I like the way you describe it, Lemus. It's very, yeah, it's very, yeah.
So yeah, in programming, if a set of live abstractions does nearly the right thing, it is tempted to use it and bend the structure of the surrounding program to fit them. We we do this all the time. Of course, it begs the question: um, what if? Because this paragraph is not um, considering this possibility, which is that maybe what you're looking for, if ever existed, would have that piece that you just picked as a substitute in there. Like the perfect example to me is a fold I, right? So the fold I function is a function that does a fold and allows you in the lambda to have an index because you want to know in which element of the container you're in. If you don't have a fold I, what are you going to do? You're going to implement one using fold. But the catch is that is it fair to say that you're bending the fold die problem to a fold problem?
I mean, you can't just use a fold by itself. You also need some way to you need some way to keep track of the number of elements of what you are folding over, right?
Well, but that can be done via a fold anyway. You just do an accumulator doing an increment.
That's fair.
But here's my question, because he may say that, hey, it doesn't fit, it doesn't rightly fit. You're gonna have to do something about it. Am I jamming a fold in a fold die because I'm using the fold to implement it? Like, at which point it's fair to say that it's a jam
I
or it is an
I
evolution?
don't I don't think this example is quite what he would have in mind. Although disclaimer, I don't know what the author had in mind because I'm not the author,
Hmm.
obviously. Uh, but I can't come up with an example off the
Well,
top of my head
Gabriel
of.
actually agrees that you should use the fold to jam it in a fold die because he says that this choice can not be doing that can lead to an inhabitable program because you'll be using parts similar but slightly different from possibly familiar ones. The only way to
Oh,
avoid this is to use small blocks rather than larger ones, or to use blocks well designed and tested by experts.
actually, I think he would argue that a fold is a sufficiently small block that this is not actually a problem.
Okay, that's fair to say. But how do you judge that? If I am using a fold, it's fine. But if am using a fold and a zip, is that fine?
Those are still relatively small blocks. I think an issue would be like, mm,
Now let's continue here because we have more to go. If you think about an example, you can say.
actually, I have an example.
Sure.
Java, before it had lambdas, if you wanted to pass a piece of code as an argument, you had to make an anonymous inner class.
Yeah,
Like
that
you have,
okay, so that feels like we are going above the threshold, right?
yeah, you have to define an entire class just because you want to pass a block of code around.
Yeah,
That's kind of,
yeah, that sounds overkill, right? But
yeah.
here's the problem. We are two people and we have a very similar taste in this area. What if to me and you, I don't know, this particular monad is fine, but someone else thinks it's overkill? How are we going to debate with them?
Well, we can argue that monads come from mathematics. Are you arguing against mathematics?
Well, large abstractions are large common patterns, and what is missing in programming languages is treatment of common patterns. Again, so he's trying to come up with an alternative to abstractions, but still keeping the common patterns. Such a treatment would need to support separating their use from their definition. Now, what would such separation mean in ordinary abstractions? The key benefit is that there would be just one place the programmer has to look in order to repair and or study. There is no reason for a language to not show the underlying, to not be able to show the underlying common parts of a pattern, right? So whatever that alternative is going to keep a very abstraction-like ability, which is to allow the programmer to has to look only in one place, because that's basically what abstractions do, isn't it? We make an abstraction, then we use it, and then we use it again and again and again and again. If you have a problem in all of those instances, you only have to look or repair in one place. That's
Yeah,
kind
he's
of the
mentioning.
gain.
Yeah, he's mentioning he'll cite an example later. I know what he's talking about, but I'm not sure if we will actually reach it in this session because I think it's in the next chapter. Maybe I don't remember actually.
The next chapter doesn't have code. The
It
next
doesn't.
section, yeah, it
Oh,
doesn't have. Only this has code.
Oh yeah, no, this is the example.
Yeah.
Yeah, I have some things to say about that
Yeah, yeah,
particular
yeah.
example.
I also have some things to say about that, but the next session doesn't have that. That doesn't
Oh
have
right,
code.
it's the quality without a name. There's no code there. You're
Yeah, yeah,
right.
yeah. It's the most interesting section so far. It's the one that I want to achieve. But anyway, let's continue. So here's an example, right? So here we have a binding, which because of this we know we are mutating it, and this is doing some sort of a loop and updating the value of this binding. So this is a very common pattern, right? It is easy to see as a pattern people, but it is easy to see as a pattern people learn and which cannot be easily captured by traditional abstraction. Well, I don't know if I would argue that cannot be easily captured by another abstraction. I don't know if I would argue that.
I mean, folds are a thing, right?
Exactly. Like, what is this if not a fold?
I mean, even if it wasn't a fold, it was some other more complicated loop. Like there are ways to make abstractions for loops if you have proper tail calls. I don't see this as not an abstraction.
Yeah. The um, Well, then he goes further. There isn't too much one can do to systematically modify this pattern, but there is a lot that programmers gain from knowing this pattern and later coming upon a piece of code that contains it. That's true. It would help them know why the obscure looking variable is popping up from place to place. It would help them see in their mind's eye the whole pattern with the intervening portions deleted. Yeah, so there is one argument being made here, which is that some patterns, although they are abstractable, maybe we should not do that. Because maybe we want the programmer to look constantly at some patterns. And that's going to be important later on. One way to lay a foundation of common patterns is the same way we do with natural language. Again, as I said, I don't know, half an hour ago, he's finally going to reach the counter argument, which is teaching. People can in fact improve. Look at that. We never think to teach people how to create words, although poets try. Yet we teach budding programmers to create their own vocabulary, but we don't provide a catalog of common patterns of usage, which is our fault, the teachers, right? So, but this paragraph indicates that Gabriel understands that we can actually improve. So we are not stuck with the vocabulary that we currently have. We can actually add stuff to our vocabulary. But that means, in contrast, that we need to spend more time teaching. How much time do we spend reading in our ordinary education? And from our reading, we gain foundation for writing. In turn, this foundation is sometimes expanded by careful instruction and tutoring in writing. Certainly, many people who write for a living go through this process. But in programming, we just learn the language and solve a bunch of short puzzles, sort of like writing 50 limericks and then off to write books. So what is hard arguing is that this is solvable. This problem of okay, maybe people don't know what is a fold, and then they write this every time. Sure. How to solve that? Well, you teach them. You actually teach them. The problem is that this type of teaching, which is basically reading great programs, that is not usually the case. And then you go to another example, which is a map car example. This takes a function f, applies it to each element of the list, and binds the list of results to those applications to the variable result. An average programmer knows a map car traverses the list, so there should be some tricky way to make the map car do double duty, computing the length of the list as well.
Yeah, I have words about this.
Oh, yeah, yeah. But what is the argument being made? Well, I'm going to jump a few paragraphs, but the argument being made is that if you actually had map car implementation copy pasted here instead of abstracting that out to a function, it would be potentially more clear how you would be able to do double duty on it.
My I would counter argue that you shouldn't need to do double duty to begin with if you had used a proper data structure because linked lists are terrible.
No, but that doesn't matter. The data
It
structure that you're using here would suffer
It
the same
actually
problem.
no, no, it actually does because the example he's giving is okay. I want to count the number of elements in the list, right?
Sure.
The reason you need to do that is because the list does not know its own length because it's a linked list, right?
Oh, wait. Okay, so your argument is that you know ahead of time that you're gonna actually need the length of your data structures, and then you're gonna pick the ones that satisfy the requirement before everything starts.
Yeah, just if this was closure, I would say, dude, just use a vector. Counting the number of elements of a vector is constant time. That's guaranteed.
Okay, I think you are right, because what is the argument being made? The argument being made is twofold. There's two things being solved by Gabriel's attempt. First, if this was written directly as this thing, you actually can see better how to solve it, right?
This thing solves the problem, but it introduces mutation, right?
No, 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 that's fair. But what he's trying to say is that, hey, what if you want to do double duty? What can you do? You can actually do two. Well, he's providing two alternatives. You provide a third one, which solves everything and doesn't introduce the problems that his alternatives will introduce, which is that, hey, just call a node your abstraction. But then he counters that, saying that, yeah, but this is inefficient, right? So because you don't know what these function calls are actually doing because it's abstracted out. So, but you know these are two different function calls. So
Well,
there's
you
a
know what the yeah, that's where my counter argument comes in. You know what the data structure is. You know you can't get the length in constant time, so use a better data structure. Like the problem is not that you have to call length. The problem is that you're not choosing the right abstraction to begin with.
yeah, no, as I said, you solve one of the problems, which is how do you make it efficient, right? How do you make it efficient? But Gabriel is also saying that if you wrote it like this, if you wrote it like this, even a novice Lisp programmer would understand that, which basically making the argument that this is not overcomplicated. So you should prefer that rather than this because of performance. But then,
Well,
then your alternative is, okay, let's say that in the beginning of times, a list was sufficient for the requirements that you had on hand. Then the 1 year comes along, and now you notice that you have to compute the length. Then the question becomes, what are you going to do? Are you going to replace list everywhere? Or are you going to go this? Or are you going to go this?
yeah. Let this be a lesson to the people watching the video in the future. Don't use linked lists. They are simple to implement, but they are actually terrible.
Okay, everything boils down to don't use these people. Okay, but anyway, let's continue because I want to read through this because this is a debate going on. There's always to be some object somewhere that is accumulating the length. You know that, but there is still the access up to the accumulator. So if you really want to have the abstraction reign, you will do this. Here, the shaded area indicates the place of sufficiently smart compiler. Yeah, so then he's making an assumption that although this is not performant, a sufficient smart enough compiler will be able to fold these two operations into one.
The
Uh,
sufficiently smart compiler is actually it's kind of a joking way of saying, hey, this code is inefficient. You're relying on a
do
miracle
magic.
to make it
Do
efficient and
magic.
do magic for you. Yeah.
Yeah, actually, there's a lot of ways. Well, that debate of do magic, it's a separate debate. We can have this discussion after the recording, but we are already over. Let's try to finish this. Because I can see value in saying, I want to write my program in the way that I think. If it's inefficient, that's your problem, not mine. Because when you're trying to make something efficient, a lot of the time, if you go for efficiency, you have to do a trade on understanding, readability, and correctness.
Or you can use a better data structure.
Well, but in this particular case, there's no suffering semantics. We don't know why you chose a list in the first place.
That's the thing. I would argue that this is not abstract enough actually, because it's assuming that a list is a linked list, which is a particular way to implement a list. It's not a good way, I don't think. It's a simple way, but it's not good because, well, there are performance problems. You
Well,
could just as convincingly say, okay, this is an abstract list type, and this I guarantee that this for this whatever implementation this uses, you can get the length in constant time. Here you go. And then behind the scenes, this could be a closure style vector, it could be a finger tree, it could be any number of structures.
no, I agree with you that in this particular case, it doesn't make sense to not do that. I'm just saying that I think applying that as a general thing can lead to problems. Because there may be a reason that a particular data structure was chosen. There may be a reason. Anyway, so then in this case, that the programmer might have made the optimization by hand, and the environment would simply show the unoptimized code. This environment feature may also aid to the piecemeal growth by maintaining a history of the software evolution.
Yeah, this is basically arguing for a sufficient, like it's saying, okay, this requires a sufficiently smart compiler, but we could just as easily have a sufficiently smart IDE.
Yes, yes. Which, well,
Which which is dumb. You're expecting your tooling to do magic.
yeah, I disagree with you on this. I want the tooling to not be dumb. I want the tooling to not be dumb, actually.
One thing is for the tooling to not be dumb, but another thing is to expect it to do magic.
Yeah, but that a sufficiently smart tooling is indistinguishable from magic. That's the catch. You may not know how it does it, but it does. And that, again, that's a separate debate. We can discuss that later. But for this particular purpose, this is like your solution completely blows this out of the water. This formulation also correctly respects the abstraction of both operations, the map car and the lathe computation, but incorrectly overemphasizes abstraction because the unabstracted but common pattern code is just fine. This is you don't have a skill issue. This is basically what this is saying. So you can understand this every time, and it requires a lot less mechanics than the environment approach just before it. Further, note that the length computation wins like a vine from the outside of the map car abstraction to its inside. And now we go to another. I don't know. I'm not a Lisper, so I don't know how controversial this is, but it sounds controversial, which is the data flow and control flow abstractions. Not data flow, data abstractions and control flow abstractions. So then he goes to say about the Fortran abstractions. So you have arrays and iterations. So the arrays are data abstractions and the do loops are control flow abstractions. And because they were co-designed, which means that they were designed meant to be used with each other, it actually feels very natural and very efficient to use them in combination. Um, then he goes further, saying that this is not an accident. One can hardly ignore the need to refer to individual elements in a matrix or a sequence while performing nested sums and products in a numerical computation. That's very fair to say. Uh, but then, well, that meant that we recognize a need to be able to define data abstractions, but it was never recognized the need to define control flow abstractions. Some languages like
Uh,
Lisp adopted a powerful macro facility which enables programmers to define their own abstractions, control ones. But macros also enable programmers to define their own data structures by providing a means to define a protocol that is syntactically the same as a generic function invocation.
I would argue you don't even have to go as far as macros. You can just use as long as you have proper tail calls, you can just use higher order functions.
That's another example of controlling the control flow. But then he goes to the what I think is a controversy. After the 80s, the use of macros to define control structures became a forbidden style, like a lesson of the dark hold of programming. Not only did some organizations outlaw such use of macros, but it began steering the programmers away from using them at all. Procedure abstractions are acceptable, but not control abstractions. The only acceptable control abstractions, at least today, at least at that time, were function invocation, do loops, while loops, and go statements, non-local exits, and a few mapping operations. Well, I'm not a Lisper, so I don't know what else you can create out of these?
Uh, I think he's talking about the loop macro in Common Lisp indirectly.
Ah, okay.
Because the loop macro is really complicated and really powerful and really. I I don't really want to say general, but yeah, I can do a lot of stuff with it. But it doesn't look like Lisp at all.
Okay. Uh, so the mismatch example shows how one sort of abstraction can be used to implement control abstractions. Some of the arguments specify functions' control behavior, such as the direction of the search, how to extract the data, how to test if the item was found, negation. But the common pattern, generalized search, generalized extraction, generalized test, and gratuitous negation, they are completely eliminated, and all hope of understanding a code fragment invoking this abstraction rests with being able to understand the name of the function and the meaning of its arguments, which is fair to say. You didn't provide all the power to the people, but you provide some of them, and in order for them to understand what they have, they need to understand the naming and the meaning of the arguments. So then he does a comparison that I don't know if I am stupid, but he says, does the following code fragment, boom, seem easier to understand than this pattern of use? Which, well, you can tell me, Marinho, what do you think?
I would rather go with the mismatch because here's the problem. With the mismatch, you're saying, okay, I'm actually describing what I want, right? It's more declarative.
Yeah,
And sure, you don't know the specific details of how it's going to accomplish. You can extrapolate based on what you asked it to do, but you don't have to deal with like this pattern of use that he gave is actually using like a loop macro, which is like you're adding mutation, you're using explicit subsequences, which like well, you're doing linked lists, which is like not ideal to cut stuff away from the end. You're doing two reverses, and it's like
yeah. like, when I read this, I was like, okay, maybe I am stupid because he says the little code fragment is an example of a common pattern. If you have been taught to see such patterns, they are as easily understood as the shorthand mismatch call. So he's basically saying that if you read this and not immediately see the parallel with this, you have a skew issue. Simple as that. Um, Furthermore, if you're not being trained to understand either the mismatch or the common pattern, you can still understand the common pattern just by reading it. And that's
I
a
would
little bit
argue that
ironic because this is
I would argue that
declarative.
yeah,
Like, this is more declarative than whatever you were doing. And if you're using any common sense definition of declarative, that means that the mismatch is more easily understandable just by reading it.
like if you scroll up back to the mismatch call, I have some issues with this function because like look at that. You're passing it 1, 2, 3, 4, 5, 6, 7, 8 parameters. That's a lot.
Yeah, that's
But
a lot.
it is describing precisely what you want without precisely how you're gonna go about doing it, right? Because you don't really care about that as long as it's reasonably efficient.
Yeah, but then he goes to say what are the advantages of the mismatch? System implementers can more easily guarantee that the implementation of mismatch is maximally efficient, coding it in an assembly if need be. So like we can go do whatever black magic we need to do if we're keeping this interface as it is and make it as efficient as possible. That's the first. It is harder to type the longhand common pattern than the mismatch expression. This takes more characters. And I think that's also true. I didn't count, but it seems true.
Even if you don't count the characters, this certainly has more syntactic elements very easily.
That very easily. The first problem goes away when computers are fast enough. Okay, so here's the catch. So he agrees with me and disagrees with Marin that there may be cases in which we actually just want to write what makes more sense to us as humans. If it's going to be efficient or not, I personally don't care. I just want to be able to express what my mind tells me makes sense. And if it's slow or if it's fast, that's a computer problem, not a human one. Because we use the computers to solve the problems. And if you want to bend us to the limitations of the computer, how are you going to make sure that you are not bending the problem to fit the computer's constraints.
You
Eh,
know, I just thought of something. This is another case where the fact that you're using a linked list works against you, actually.
no, but what I'm telling you is that I don't care if it's a list or a finger
No,
tree.
no, no, no. Because if you had efficient concatenation and slicing as primitives, which you don't have with a linked list, this code fragment would actually be much shorter and much more easy to understand because you just say, okay, I'm going to I'm going to slice the list, the sections that I'm interested in, right? Which is equivalent to passing the start and end arguments to mismatch.
Yes.
And then I can iterate from the end instead of from the beginning, which with an abstract list, if it's a finger tree, you can step through from either end, it doesn't matter. With a linked list, you're forced to start from the left, right?
Yes.
So like, this argument would actually be a lot stronger for using this pattern if he had used a better data structure, ironically.
No, no. Yeah, but that's a separate point though. Like what he's saying. Let me re-emphasize because I think you said correct stuff, but that's not the point. The point is that this problem goes away if computers are fast enough. What is he saying? He's saying that what is the advantage of using the mismatch? The advantage is that because this is declarative, you can do whatever shenanigans, whatever hacks you need in the definition of mismatch to make this as efficient as possible. So what he's saying is that one of the advantages that he's listing of using this instead of this is that this allows you to have a decoupling between implementation and using it,
Yeah.
which if the computers are fast enough, who cares if it is optimized or not? Because people like you, which wants to optimize and make sure that everything makes sense, you would totally say, dude, just swap this linked list with a finger tree and you're done. What he's saying is that if computers are 10 times or 100 times faster than they are today, who cares if it's a list or a linked list or not?
You will care because a linked list doing this from the end is actually,
The
let's see,
complexity will never change, but we are talking about the time that you're gonna be like. Imagine an interactive system. If it's a linked list, it takes 2 seconds, and if it's a finger tree, it takes 2 milliseconds. Sure, fine. Then, in 100 years from now, a linked list is now 2 milliseconds, and the finger tree is 2 nanoseconds. Who cares? That's the point. That's his point. What he's saying is that even if you use one of the most inefficient things ever, if you assume that computers will become fast enough, you actually don't need to care.
the problem then is that you have to assume that computers will be fast enough. That may not be the case. What if you're writing stuff for like a microcontroller or something?
That's why we still care, which you're completely correct. If you're doing a fridge, if you're doing the controller that works with your gate that you use at your house, these type of things, that commodity, those processors, they are not fast enough for us to allow us the luxury of not caring. Hence, we care. But like his argument is so on the future. Like I don't know when this was written, but we are talking at least 200 years probably to reach a point in which nobody has to care in all scenarios. Your fridge can be using a linked list and it's fine. I'm not saying we should do what he's saying. I'm just explaining to you his argument. So that's the first thing. And then the second problem, well, the second advantage that he's pointing by using mismatch instead of this monstrosity is that a well-designed programming environment or uh, wait, the second goes away with a well-designed programming environment or doesn't matter at all when you consider the availability gains from using an easily understood program. So what he's saying is, whatever you lose by not using this, you gain it back because people can read this.
Yeah, I disagree with that.
I disagree totally with that. uh, and then he goes, well, now we go to LSP land. There is no reason that the shorthand mismatch expression could not be simply an abbreviation for the longhand common pattern, which is what's supposed to be a function supposed to be anyway. What else should it be? And then the programmer can decide which one to to look at. To me, that would be an okay LSP feature. I would never use it, but you can. Uh, so then we go to let's consider the scenario in which the interface to a data abstraction is being extended. We've added to the interface and need to modify our program to invoke the new parts. For example, additional state must be initialized and maintained. The problem of adding invocations for the new part of the protocol is exacerbated by the fact that only mathematical Fortran-like control structures are available. Over the years, programmers have got into the habit of optimizing the use of control structures for their efficiency or style. Typically, the most compact control structure for the specific job at hand is often preferred to a more general formulation. Modifying such optimized control structures sometimes requires a large structural modification of a program when only small modifications seem necessary. For example, the initialization information might not be available at the point we need, and we must be structured or saved somewhere, and only part of the initialization information might have been computed because earlier not all of it was needed. So it's basically saying that we are custom ourselves instead of building new control flow abstractions. We rather do hacks and flags all over the place to do the intercommunication between multiple primitive control flow abstractions. Um, yeah, this problem with the abstraction stems from mixing a fixed set of control abstractions with custom design data abstractions. If natural control abstractions were matched, they must be implemented non-abstractly using low-level primitives. That is, through older control flow abstractions, which is what I just said. Even though there is a pattern of control, there is no way to abbreviate it except through procedural functional abstractions. And then he goes to the example of the flag, right? So right next to a protocol invocation that represents an opening of a floodgate would be the assignment of one to a flag that tells a later part of the program that certain initialization already took place. So if you don't have the capability to make your own custom control flow abstractions, you're going to have to glue existing primitive ones, ideally tested ones, so like experts made them and it's already tested and it works, but you may have to keep some state information crossovers, like I already did this in this part of the flow, I'm informing you that this was already done before, so you need to do something different in that case, and so on and so forth. Uh, And then he says, regardless of what you think about it, it is certainly true that because almost every programming language does not allow any sort of meaningful user-defined control flow, there is always a mismatch in abstraction levels between control and data. If there is a good reason for allowing data abstractions, why there isn't that a good reason for allowing control flow ones? And if you're going to disallow one, why not disallow both then? It is accepted, nevertheless, the practice to use existing control flow abstractions to implement others using common patterns. My argument is that perhaps we should be more willing to use common patterns for other things as well, which I don't have much experience with. I don't feel the need of creating control abstractions in my workflow, so I don't know how much of a pain this is, but well.
Well, you're not usually in the business of implementing custom data structures. That's why you don't feel that need.
Um, but he says that even if you, in that case, you would, because here's what he says. The use of procedure function abstractions only pushes the problem down one level. Within the procedure or function, the implementation of control is fully exposed, even though the objects are being manipulated with data abstractions. Like my understanding is that he's saying that even using non-custom data structures, you're gonna also feel the need eventually. That's what I understood from what he said. Is that wrong?
Uh, mm, I'm not sure actually. Then again, you're already used to using folds, and folds are pretty universal, you know? So,
That is very fair to say. Then he says the real reason that common patterns are not used rather than tight abstractions is efficiency. It is more efficient to write abstract compressed code than uncompressed common patterns. It is more efficient to write abstracted code in some cases. For example, if we were to write two lines that do the map cardinal length, they would run about as twice as slow as some complex compressed version. These would matter if computers are big enough and fast enough, or you use a different data structure. So we continue to pay with a suite of people so that computers can make it easy and users don't have to be inconvenienced. Perhaps someday the economics of this situation will change, maybe not. Well, again, there is a third route, which is swap the data structure and just don't put all your money on the bet that computers eventually will be fast enough.
Yeah.
Uh,
Data structures are important. You should learn them.
yes. Um, and then he goes to to Alexander's pattern languages. A pattern language is a language for generating buildings and towns with organic order. Patterns generally specify the components of a portion of a building or a place and how those components are related to other patterns. So, there's an example. Locate each room so that it has outdoor space on at least two sides, and then place windows in these outdoor walls so that natural light falls into every room from more than one direction. Uh, and then he says that, well, that has 15 years of age. I've been free quoting those because I'm trying to understand how to make those parallels. These patterns and the social process of applying them are designed to produce organic order through piecemeal growth. Clearly, there is a connection between what Alexander is defining and half of the definition of the abstraction. But we don't have time for that. Not only him in the book at the time, but we also don't have time for that. So here's the summary of what you should learn or should have thought about during this essay. Object-oriented languages gain their power from compression, which can lead to compact, efficiently expressed programs. Compression, though, can present problems if it's prematurely used. I don't think anybody has anything against that. Software
Nope.
development is always through piecemeal growth and rarely throughout design. Such
Thorough
planned
design.
development
Yeah.
can lead both to technical problems because the nature of a piece of software cannot be known, and also to social problems because completely planned development alienates those developers who are not also the planners. Half true, because again, seems more like a narcissistic slash egotistical way of looking at it. But this part of wanting to have a complete global plan design, it's very unlikely to happen. It's very static if you're using that definition.
Yeah. You don't know the future, right?
You don't know the future.
You can only
Habitability,
you can only speculate about the future, but you can never be certain.
yeah. Habitability is one of the most important characteristics of software. It enables developers to live comfortably and repair or modify code and design. This is true just by itself, but it begs the question, what if the problem you don't feel that is habitable because you have a skill issue, not because people made it inhabitable? When taken to extremes, abstraction can diminish habitability and can result in premature compression. Be aware of abstracting and or of abstracting when common pattern would do. We, I don't know about you, but I don't feel we explore this because to me, there is no other way to extract a common pattern outside of abstracting it out. He tries to do that with this LSP feature. Where is it?
Yeah.
There is an LSP thing that he mentioned that you can swap if you want the compressed version or not, but they are actually one-to-one. What is that then, if not a function or a macro, which are abstractions? So I actually don't really understand what he means by there is a way to extract a common pattern that is not an abstraction. I don't really follow that. And we're gonna die not knowing everything, basically,
Which is fair.
which is very true. Well, uh, 1 hour and a half it took us. Well, I was very certain, I was very uncertain that we would be able to do two today because this chapter is gigantic. But anyway, I think the conclusion is kind of right in the sense that you should not over abstract, and usually programs that have that are nice to work with, they tend to have abstractions that are quote shallow. I don't think they are shallow at all. I think they are kind of fantastic. It's kind of like amazing that someone identified that the pattern that was worthwhile to abstract was that one. I don't think that is shallow at all. I think that's very deep and philosophical in a sense. But if you're gonna say shallow in the sense of how many layers, then I can start to see some sense in that. Uh, um, so knowing which parts to ignore slash abstract is deep, but usually those decisions, deep decisions, they end up being thin layers. If that
Yeah,
makes sense.
like the notion of a functor map is like, okay, I have a container. I want to do a thing that is the same to every element in there. Like
Yeah.
that's a deep notion, but like it's just one decision. It's in terms of like layering of decisions of what to do. That's like one layer. It's very shallow.
Yeah, it's very shallow in the if you count how many abstractions. Well, we talked about the habitability problem, but at least now he considered, well, he himself considered that, hey, have you ever considered teaching people? Uh, so that's an improvement in comparison to the other sections, previous ones.
And yeah, and the other big lesson is don't use linked lists. They are
Yeah, yeah,
terrible.
don't use linked lists. That is one way that he didn't mention that you can get out of this dilemma. You can either bet that computers eventually will be fast enough, which I bet they will. I don't know if we're going to be alive to see that happening, but they definitely will. There is the case of copy pasting this everywhere, and there is also the case of just swapping the linked list. And I think he's underestimating the power of the third. Uh, well, yeah, that's it. I think that's those are our conclusions. Do you have anything else before I finish?
I really like this book.
Yeah, the book is great. So I'm gonna finish the recording now.
Bye